Welcome to our training on an engineer's guide to relay outputs. We will be introducing relay outputs, exploring relay outputs versus solid state outputs, the difference between relay outputs and digital outputs, modules with configurable relay outputs, Modbus RTU relay output modules, Modbus TCP relay output modules that get triggered based on digital inputs, relay output modules for use with SCADA software, and more. Relays are switches that open and close circuits. When a relay contact is normally open, the contact is open when the relay is not energized. When a relay contact is normally closed, the contact is closed when the relay is not energized. Applying electrical current to the contacts change their state. Relays are used in many different kinds of applications, including appliances, automotive, lighting control systems, motor drive control, electrical power protection, and traffic control. ICP DAS USA provides industrial automation equipment for monitoring and control applications. Our equipment's low DC voltage and supports wide operating temperature ranges. We provide fast service, free technical support, free control and monitoring software. We ship orders out within about 1 week, and we provide a 1-year warranty against factory defect. ICP DAS was established in 1993, and ICP DAS USA was established in 2001 to support the North and South American markets. I'm Maria Santella, sales manager here at ICP DAS USA. I've been with the company for 12 years and previously held positions as application engineer, technical sales engineer, and web developer. Robert Morau, our senior technical application engineer, he has extensive support and experience with pre-sales and post-sales technical support, testing, troubleshooting, and application development. He's been with ICP for 12 years, and later in the training, he's going to be giving a live demonstration of using relay outputs with SCADA software. Please go ahead, enter in your comments or questions, and we'll be answering them. If you want to go over any kind of applications, let us know. Relay outputs are designed to enable, interrupt, or regulate the flow of electrical current to external equipment, facilitating control over processes and systems. An electrical signal is used to turn a relay on or off. Traditional relays use an electromagnet to control a switch. Some relays, like solid-state relays, use electronics. Relays ensure electrical isolation between two circuits. There's two circuits in a relay. The first circuit controls the operation of the relay. A manual on or off switch or timer could be connected to the first circuit for control. The second circuit is connected to the load that needs to be controlled, which could be like an electrical device like a light, fan, compressor, or a motor. A coil on the first side generates a magnetic field when current passes through it. An electromagnetic field is created when electricity passes through a wire. A wire wrapped into a coil creates a larger, stronger electromagnetic field. The magnetic field is controlled by controlling the current. When the coil is energized, the relay is actuated. Most relays are normally open or normally closed types. When a relay contact's normally open, the contact is open when the relay is not energized and the load is off. When a relay contact's normally closed, the contact's closed when the relay is not energized. Applying electrical current to the contacts change their state. Input terminals are where the coil's connected, and the output terminals are where electrical current flows out through to external devices. Form A relay contacts are single pole, normally open contacts, like a single contact normally open switch. Form B relay contacts are single pole normally closed contacts, like a single contact normally closed switch. Form C relay contacts are single pole double throw contacts. Relay outputs are available with a common terminal and as isolated contacts. An output unit with 3 Form C contacts that have a common terminal is shown in diagram 1 on the left. The common terminal of each of the 3 relays is connected to one common terminal of the output unit labeled output COM. Since these relays have one common terminal, power supplies associated with the driven outputs must have one common connection. Each output has 2 labeled outputs, NC, normally closed, and NO, normally open. The NC and NO have a number, which is the number of the output associated with the terminal. When an output's turned off, the output COM terminal is connected to the NC terminal associated with that output. When the output's turned on, the output COM terminal is connected to the associated NO terminal. In diagram 2 on the right, you see a typical connection diagram for a relay output unit with 3 Form C contacts with common outputs. The power source shown is an AC supply, which could be 120 VAC building power. The wiring shows lamp LT1 will only light up when output 1 is turned on because the lamp is connected to a normally open terminal for output 1. Lamp LT2 is connected to the normally closed terminal for output 3, and the lamp will be on whenever output 3 is turned off. If the PLC were to lose power, lamp LT2 would light up since there would be no power to energize the output relays in the PLC. In the latter diagram, program running in the PLC, output 3, could be programmed as an always-on coil. While the PLC is powered on and up and running, lamp LT2 will not be lit. If the PLC loses power, lamp LT2 will light up and provide the operator with an indication that the PLC had a problem. These lamps that light up based on the PLC, whether it's powered up or not, this could help when troubleshooting the system and quickly show exactly what needs attention and repair. Coil K1 there is shown and connected to output 2. This could apply to a solenoid driving a plunger into a slide, locking it into place, or a motor starter coil for controlling power to a motor that requires more current than the relay in the output unit can safely carry. Coil K1 would have to be rated for AC use, in these cases at the voltage available from the AC power source. The wiring of these outputs is similar to a switch controlling a light bulb. A normally closed switch or a normally open switch could be used. A switch placed in series with the light bulb and the power source would control current to the light. Relay output and solid state output, they're both used in industrial automation for controlling systems and external devices, but their technology characteristics and applications are different. Here's a comparison. Relay output modules, they use electromagnetic relays. They consist of coils. They generate magnetic fields to open or close mechanical switch contacts. When the coil is energized, it physically moves the contacts to make or break electrical connections. Solid-state outputs use semiconductor devices, usually triacs or transistors, to switch electrical loads. Triac stands for triode for alternating current, and it's a bidirectional semiconductor device with 3 terminals that control the flow of current. A transistor is a semiconductor device that controls voltage or current flow, amplifies electrical signals, and acts like a gate for them. Solid-state outputs don't have physical moving parts like relay modules, as their switching is electronic-based. Durability. Relay outputs are robust and capable of handling high current and voltage loads, so they're suitable for heavy-duty type applications. Mechanical relays, having the physicalness about them, those can wear out over time due to the mechanical moving parts, which can limit their number of cycles, which may be hundreds of thousands or millions, but it does have that limitation. Solid state outputs have a longer operational life because they lack mechanical components that can wear out. Relay outputs have slower switching speeds. They're very fast, but they're slower than solid state outputs because of the physical mechanical motion of the relay contacts. Solid state outputs offer rapid switching capabilities, so there's no mechanical delay, making them ideal for applications requiring precise and high frequency control. Relays, they have excellent electrical isolation between the control circuit and the load. That enhances safety and it protects electronics. Solid state modules do have some, or they can have some level of isolation, but it's not as robust as the relay modules. Special precautions might be needed in applications where high isolation is crucial when using the solid state type. Relay outputs are used in so many different kinds of applications, um, like controlling motors and heaters. They also are used a lot where you need the electrical isolation, like safety systems. They're also used in semiconductor manufacturing. They're being used to control motors. They're used in manufacturing and robotics, like unmanned aerial vehicles and building automation for controlling the lighting, the air conditioning systems, also for different security equipment. Some of them are used to open or close automated doors for safety, like in a case of earthquakes. They're also being used in energy management systems. Some relay output and solid state output boards that we provide include the RM216 and the DNSSR4. DNSSR4 is a solid state relay module that we provide. It has 4 optically isolated Form A type digital output channels. RM216, that has 16 Form C 5 amp power relay outputs. Digital outputs are in fixed states. So they're either on or they're off. There's no state of half on, half off, or in between. If it was a dimmable type light, for example, that would be analog. Digital outputs are used for semiconductor devices like transistors or solid state relays to control electrical current flow. Digital outputs are electronic switching devices. They don't have moving parts. Relay outputs include mechanical switching through electromagnetics with coils that generate the magnetic fields we discussed, that physically open or close the mechanical switch contacts. And those kind of contacts, when they're closed, they allow electrical current to flow through. In addition to the daughter board type of I/O equipment for the relay outputs and the solid state outputs, we also provide remote I/O, and we also have configurable I/O that can be set up to trigger outputs based on inputs. They communicate over different protocols. This one is a WISE 7160, communicates over Modbus TCP, so you can use it with SCADA software like shown here. So you can have buttons set up on the screen in the SCADA software or show different measurement levels for different equipment attached to the terminal block sensors. These WISE 7160, they allow for setting up if-then-else type logic rules through web browsers. They communicate over Modbus TCP, so they're also being used with TPD 433 touchscreen PLCs that communicate over Modbus TCP, and they're being used for monitoring and control. So the relays, they handle high current voltage loads. They also help with protecting sensitive electronics. When properly maintained, they have the long operational lifespan. They're also used in many different kinds of applications. ISN 101, it's a liquid leak detection module we provide. It's very low in cost and it detects liquid and can trigger relay outputs based on detecting liquid. So they're being used in water and sewer pipes in buildings. They're helping to prevent extensive property damage. They're also helping with saving water and resources and also helping to prevent bigger issues. They're being used with our WISE IoT controllers. So they're sending out signals and alarms. They also connect back with SCADA systems for monitoring and control. Our liquid leak detection modules, they have accessory cables that you connect with them, and they support up to 500 meters. There's also ones that have the break detection. ISN 104, it has 4 relay outputs, communicates over Modbus RTU. They're being used with touchscreen controllers like our TPD and VPD series. So the touchscreens, these are showing the status of different areas of the building. The screen has menu and different buttons that you could use to get to different sections in the application. These are being used in warehouses, libraries, museums, also at refrigeration systems, cold storage facilities, data centers. And they're also used with water tanks for monitoring leaks. The ALM 04 MRTU, these communicate over Modbus RTU and they play MP3 alarms based on digital inputs. They also trigger relay outputs that are being used to trigger lighting. Also for some applications, they're being used to open doors. So they're used in a lot of different kind of safety applications. The audio files are stored on a micro SD card. They have 8 different kind of alarm modes. The AR200 is for vibration monitoring and control, and they are being used to trigger, they have onboard relay outputs that are triggered based on the vibration levels for helping to save sensitive equipment like servers. Our Ethernet I/O modules, they communicate over Modbus TCP. These support I/O pairing. So based, excuse me, based on inputs in one area of a building, they're being used to trigger relay outputs in other areas of buildings. And they're both connected to the same Ethernet network with Ethernet cabling. They have IP addresses, and the configuration for the I/O pairing is done through the web browser. You just set it up once and then it just works. So that's a great logic control function that you could implement without having to get a PLC. In addition to those RM216 that I showed you earlier, we also have other types that have different numbers of relay outputs. These are being used for triggering relay outputs based on a digital output. So you send a digital output and then it triggers the relay output. We have lighting control modules that are being used for triggering lighting with the touchscreen controllers. It's saying no software is needed, but you definitely can use them with, like they're being used commonly with the touchscreen PLCs. But yeah, for example, in this application here, you can see it connects to 3 different lights and one input to that device would control the 3 lights. We also have wireless relay outputs. We have different kinds of wireless, like Zigbee. The part number would be ZT-22060, and that has digital inputs and relay outputs. What you do is you connect one of the ZT host converters to your PLC or your controller, and then the ZT2060 would communicate up to 700 meters line of sight, and Zigbee's a self-organizing mesh network, so each end device acts as a repeater to help get the communication across. And then there's also the Wi-Fi products. They can be used with existing or new Wi-Fi networks. I mentioned that we provide free control and monitoring software. This is Easy Data Logger that you can download from our website. It logs data, and it also has a graphical user interface that you can see with drag and drop type objects like bar graphs, tanks that you can map up to actual tank level. So for example, you can connect one of our Modbus IO modules, and say you had a 4 to 20 milliamp float sensor in that tank, and you were using M-7017C, for example, you would be able to see that 4 to 20 milliamp input with the tank level float sensor and see the little tank, and it would fill up accordingly to the level in the tank. And you can also put a text box on the screen and see the actual measurement. It also supports web cameras. It can log data, for example, like once every second for a year, and then you can save that in a data log and then start a new log. It lets you configure that. And if you'd like a web-based demonstration, just send us an email or give us a call, and we can set that up for you. And these also can be used to send text messages or email alarms. So now I'm going to pass it over to Robert, who's going to be showing you how to use relay outputs with SCADA software.
Okay, let's see. This is our TMR5 module. It's a Modbus RTU data acquisition module with relay outputs. I have this connected to my PC for a live demonstration. Today, I'll show you how to connect it to Indusoft or Aviva Edge, rather, just for an application where you can control the digital outputs. Let's see, we have more advanced modules for analog inputs and analog outputs and various other types of I/O, but for this demonstration, it's just strictly about relay outputs, so I'll create a demo in a few minutes. But first, I want to show you a few things. These are the statistics for the 5 relay outputs. This module has 5 relay output channels. Consider power relays, and they can accept a load up to 5 amps. We do have some modules which can go slightly higher, and we also have signal relays which traditionally are for 1 amp loads. This can handle voltages between 100 to 240 or less, and it can also handle your 24 volt to 30 volt DC signals or loads for the relay itself. The relays are controlled by Modbus RTU, and I'll show you a demo for this using Indusoft. This is the wiring diagram for our relays for this module. I don't have anything connected, but just so you know, this is a single pole, single throw relay, normally open. Let's see, when the IO status or Modbus register value of 0 is shown, it has no current flow. So the relay is normal or is open. And let's see, when the relay state is 1, it closes the relay and current flows. So this is a state of 1 for Modbus register values. The Modbus register table is shown here, or at least part of it. For this demonstration, we're going to just show the relay, or I'm sorry, digital output statuses, which are relays. In this case, this module only has 5 channels, even though the table shows 0 through 7, but this module has 5 channels, channels 0 through 4 for a total of 5. And these are the registers which will connect using our Aviva Edge software. And let's see. Oh, this is a table of some other relay modules which we have in our Modbus RTU protocol. If you need other protocols, we also have other modules, but these are just some other selections. Let me get to the section. Pretty much this section right here. This module right here, M7061, has 12 channels, and they're power relay form A, so single pole, single throw, normally open relays. And we also have some with form C down here. See, shown here like M7069 and M7068. And if you need help in choosing a relay module, please feel free to contact us. The first step is to configure the TMR5. Let me just minimize this. Actually, well, let me just show you this right here. This is the configuration for our TMR5. So currently, our TMR5 is connected to my computer using COM port 2. And let's see, it's set for a Modbus address 1 at 9600 baud, disabled, and format N81. Let's see, I'll double click here, and we can control the relay values from here if we wanted to test our outputs or reconfigure the module for other properties. We can also set a power on value so that this is the value which the relay's state is when the module is powered on. So for instance, if it was controlling something that liquid flows when the output is off, you definitely want to set the power on value for on so that liquid doesn't flow. And we also have a safe value. This is if communication is lost to the module. So if communication is lost to the module for a specified amount of time, the relay outputs would go to a predetermined safe value that you set, not just turn off, but you can set it to turn on to protect commodities from either flowing or movement or whatnot, just controls. Let's see, let me just close this so that I can close the connection. This utility is used to configure almost all of our Modbus RTU and decon modules. This right here in the background is Aviva Edge. Right now, I'm just in the standard PC demo, which comes with the Aviva Edge software. This is the control panel. I just wanted to show you this. Like right now, let's see, this demo has a power on and power off button where you could just click on, click off. We're going to simulate this in a few minutes, but just know that what would happen is when you press the button, the relay would turn off. And when you press the button, it'll simulate an on status. So the value in Modbus would be a 1, and the application would be running, or the motor would turn on, or the conveyor would turn on, or you open a valve or something like that. With this demo, it's just a control panel, but it's just one of many demos that Aviva Edge has for your industry. When you purchase the software, you can create your own using a vast library of images and other objects within Aviva Edge. Some features that are shown that I like to show are like you can do color changes based on, say, a button status. In this case, you can change the value from a red button to a green button if you wanted to show the status of the I/O. Also has bar graphs, data entry fields, and a whole bunch of other animations and types of objects which you can use within your project. Other industry examples are shown here. In this case, it's just a machinery. In this case, it's showing a press, I believe. It's building, fenders at the bottom. Okay. The wastewater. So, anything on off could be controlled by a relay. Traditionally, devices with either AC loads or higher current flow are controlled with relay outputs. And let's see, now I will close this demo and we will create a new project, which, let's see, webinar, here we go. Okay, so in order to connect our TMR5 module, we need the properties from Decon Utility, which I showed you earlier. So the first thing we want to do is create our connection to the module. The driver is Modbus R2. Let's see, it's shown here. We select that. MOD, BU, double click, we add it down here and click OK. Let's see, also when you do use this driver, if you need the help document, it's actually very helpful in helping to configure the module. Let's see, it helps you show what values to put in the main driver sheet rather, and also it shows you how to set the baud rate and parity options for the Modbus R2 connection. This is just it's available within the software. It's just you just right click and select help. In this case, I'm going to set the baud rate and parity options and COM port. So let's see, for this application, it's connected to COM2, 9600 baud 8 N1, and we're using Modbus R2, so everything looks good here. If you didn't need to change the COM port, of course, you can just use the drop-down box and select the COM port which your device is connected to. In this case, I am connected to COM2, so we click OK. Next, we must create our tags. Let's see, I'm just going to go here, insert tag. We'll call it DO0. DO1. And note that it's integer, but for digital outputs, it really doesn't matter because the values are only 0 or 1. For analog tags, it matters more so. Let's see, DO, did I do 2 and 3? I don't remember, but oh well. For this demonstration, we'll just use a couple of tags. So next we want to go here, edit our main driver sheet, and create our tags. So let's see, I think I did DO0. Our station ID is our Modbus address of the module, which in this case is 1, and our IO address is 0x:1. 0, oh, actually I have it here, but it's okay. And then we have DO1, also station ID 1, and 0x:2, DO2. Oh, I guess I skipped 2, so we'll create it this way. 1 and 0x:3. So this will set up your Modbus registers for the TMR5. We just set up the first 3, but you can just add DO3 and 4 if you wanted to as well. So now we'll create a graphics screen just to show you how it works. And to do that, we just go here to the graphics tab and we click on screens and right click and insert new screen. I usually like to call the main screen just main, and you click OK, and it creates. So you can of course adjust the size if you wanted to. If you wanted to right click and what do you call it, set the background color, we could do that. Let's just select a light color like that and click apply, and we change the background color. If you wanted to put your company logo or something, you can also do that. Just what do you call it, use a JPEG or even just copy an image and paste it into the project. Let's see, we'll use a symbol from the project itself. First of all, the one thing I always forget to put is the exit button. This, we just use this built-in library image. And then we'll use a few symbols for the IO. Let's see, first we want to create a push button, and we'll use, which one do I want? Let's go with the green one. So we just click it or double click and select it. We'll do a red one and paste or put it there. We can just add some text to label it. Let's see, DO0. Text. DO1. And then we'll also add a indicator light. Okay, pilot light. Select this one, I guess. This one works fine. And then we'll go to strong. That one looks a little small, actually. Let's try this one, actually. Okay, and to edit the tag value, you simply click on the object. Here in this case, we'll double click. Of course, it doesn't work. So DO0, and this will be DO1. There we go. That works, of course. I double clicked on it. And we can set our buttons if we want to set the tag value here. We just change it here. Tag state. There we go. DO0. And then we could run the project, and realistically, when I push this button, this should change. Yep, we're seeing a change in value, and I do hear the relays clicking. Oh, actually, for this one, I forgot to set that, but this one controls that. When I go back here, let's exit. Let's just do Control C. We'll delete this one because I don't like the look of that one. And we'll paste. And we'll just change the tag value here from DO0 to DO1. And everything should be good. So now I should be able to click this button and this light turns on, click this button and this one turns on. And these are just showing the relay states. So these buttons are used to control the relays. Within Aviva Edge, you can communicate to PLC so the PLCs can do the controls, or if you wanted to, you can create VB script or scheduling to also do some controls from within the Aviva Edge software, or of course you can do manual controls just by creating some buttons and some pilot lights to indicate the status of the digital or relay outputs in this case. Did you have anything else to add, Maria?
Oh, no, but they can always email us or call us if we can help them in the future.
Oh, of course, yes. And we can, do a one-on-one webinar if, there's a specific module you want to use or test, and we can, show you how to, add a digital output to either Indusoft or Easy Data Logger or, whatever Modbus device you have.
Oh,
I do see a question pop up. Okay, what software utility is this again? This is Aviva Edge software. This is a paid version. We also have our Easy Data Logger, which is a free version. It doesn't do as much, and it's more used for just data logging, whereas this is a full-blown SCADA/HMI application.
So it
Let's see.
supports reporting, trend graphs. It comes with a thin client. So for each license of Aviva SCADA software, you can publish your application for remote viewing over a web page. Aviva also comes with a phone app that you can use on your phone for monitoring and control. Supports alarms, reporting. You can send email alarms. It also supports animations.
Oh yeah, this demo, which comes with the Aviva Edge, definitely shows off most of the features of Aviva Edge. And if you need an industry example, Aviva Edge has a vast library of other demos, some specific for certain industries, others like if there's a certain feature you'd like to use or implement, they also have demos for those, and their application videos are very good for helping people get started. and you can download the software from our website and get a 40-hour free trial. Sometimes you can create your own project with this within that allotted time, and you can just purchase a runtime license to run a simple control panel with some of our data acquisition modules.
So I'll be sending everybody by email a link to that software, or if you want it, or just let us know, and then we can send that to you. And the free trial, it works for 40 hours. So say you work with it for 1 hour. If you close the software, then when you open it again, the clock continues. So it actually works out to be a long time. And the licenses are sold based on the tag count. There's a runtime, a development, or a runtime with a development and one license. And you can either get that as a soft key or a USB hard key. It's sold based on tag count. So depending on the tags, which are the IO in your application and also the objects, like on this screen here, you can see there's different button objects. Each of those would be a tag. Also these labels and the different objects on the screen, variables. Say you're doing some equations based on the data. The variables and different objects, those all use a tag.
Okay, and I just wanted to add, as you're developing your project, in the bottom right corner, it shows the total tag count. So you'll know how many tags you're using. I hope you can see this on my screen. It's currently tag count is 374 for this project. So if you do need to keep track, that's where the tag count is displayed in the bottom right corner. Okay, I don't see any other questions. So if anyone can, or I'm sorry, if anyone has any questions, please feel free to contact us, but we'll close this session out, but have a nice and wonderful rest of your day, and we'll see you next month for our next webinar.
Thank you.